Let's discuss about the ITTOs. First, the inputs. In it, the first one is project management plan. The four components of project management plan that are used as inputs are: first one, risk management plan. The risk management plan specifies whether quantitative risk analysis is required for the project. As discussed earlier, not every project needs quantitative risk analysis. The need of quantitative risk analysis should be mentioned in risk management plan. It also details the resources available for the analysis and the expected frequency of analysis, because to do quantitative analysis, you need specialized risk management expert and specialized software. Scope baseline. Scope baseline helps to understand the complexity of a project, which helps to understand the risk in the project. The project boundaries, acceptance criteria, constraints and assumptions are some of the other factors help to identify risk. The risk that needs to be analyzed to further are taken to the quantitative risk analysis. Schedule baseline. The schedule baseline contains project estimation that are uncertain or ambiguous. Those estimations may help to identify project risk. Imposed schedule constraints, dependencies between activities, and lack of clarity regarding milestone dates or estimates are the indicators of a risk. All these risks need to be quantitatively analyzed. Cost baseline. The cost baseline describes the starting point from which the effect of individual project risks and other sources of uncertainty can be evaluated. The next one is project documents. There are 10 in it. First, assumption log. Just like in qualitative analysis, assumptions and constraints that are recorded in business case and project charter may be the first-hand information to individual and project risk. Reviewing and analyzing the assumption log may help to identify new risk. Basis of estimates. The basis of estimates used in the planning of project may be reflected in quantitative risk analysis process. This may include information on the estimate purpose, classification, assumed accuracy, methodology, and source. Cost estimates. In a project, typically you have cost estimate, duration estimate, resource estimate. If you know what are those estimates and the basis of estimates can help you to determine risk in the project of not meeting those estimates. Cost forecast. Cost forecast can be compared or reviewed against the cost risk analysis and the schedule forecast. This can be reviewed along with the schedule risk analysis. In fact, this comparison can give you insight whether the cost and schedule estimates are realistic and are they likely to be achieved. This can help you to determine any associated risk. There are many forecasts are done in projects such as project estimate to complete, estimate at completion, budget at completion, and to complete performance index. These values may be compared to the result of quantitative cost risk analysis to determine the confidence level in achieving the targets. So, you need them as inputs. Duration estimates. Schedule variance in duration estimates can provide a starting point to perform quantitative risk analysis. Milestone list. Quantitative risk analysis provides when the risk is likely to happen. The milestone list provides key events list in the project. These two lists are compiled to determine the confidence level of achieving the target. Resource requirements. Upon reviewing the resource requirements, the project manager can estimate the risk related to resource, such as lack of number of resources to complete the project. Risk register. Typically, the risk register will contain details of individual project risk, so they become an input. Risk report. Risk report includes information about overall project risk response strategy, and planned responses. Additionally, they do have information about the number of risk, type of risk trends, metrics, and risk sources. This analysis can help to determine which risk will have higher impact in the project. Just remember, risk report is iterated throughout the project. Schedule forecast. Forecasting will have impact on quantitative risk analysis. Forecast may be compared to the result of quantitative schedule risk analysis to determine the confidence level associated with achieving these targets. The third input is enterprise environmental factors. Industry studies and similar project studies, published material including commercial risk database or checklist, organizational risk appetite, tolerance, and thresholds helps you to identify the impact of risk, rank them, and determine which response strategies to use. The fourth and the last input is organizational process assets. Information from similar past completed project is one of the key input from OPA. Now, tools and techniques. First, expert judgment. For this process, the experts can be from translating information of uncertainty into numerical input, selecting the most appropriate representation of uncertainty, modeling techniques, identification of most suitable tools for the selected modeling techniques, and interpreting the outputs of quantitative risk analysis. Data gathering. Here, we are talking about interviews. Interviews may be used to bring out individual project risk and other source of uncertainty. This is particularly useful where information is required from experts. Interpersonal and team skills. Facilitation. Facilitation improves the efficiency of the quantitative analysis of individual project risk. Representation of uncertainty. Estimation will have uncertainty. Estimations will have uncertainty. It can be in duration, cost, or resource requirements. In uncertainty, the range of possible values can be represented as probability distribution. They help to figure out the risk. Data analysis. Here we have simulation. The quantitative risk analysis uses a model that simulates the combined effects of individual project risk and other source of uncertainty to evaluate their potential impact on achieving project objectives. Monte Carlo analysis is most often used as a simulation method. This uses schedule network diagram while analyzing the schedule risk. The simulation uses project cost estimate while analyzing cost risk. An integrated quantitative cost schedule risk analysis uses both inputs. During the analysis, the input values such as duration estimate, cost estimate is chosen randomly for each iterations. The iteration is carried out several thousand times. The output represents the range of possible outcomes for the project such as project end date, project cost at completion, etc. The output represented as histogram or cumulative probability distribution, also called as S-curve. This helps to understand the probability of achieving the outcome. Let's look at an example of S-curve from the PMBOK guide page number 433, figure 11.13. Here, there is a 23% of chance that the project can be completed within 2.2 million and 85% chance to complete the project within 2.45 million or less. Quantitative schedule risk analysis can be used to determine which elements have the highest effect on the critical path. This helps to focus on those elements to achieve schedule performance. Next, sensitivity analysis. It's a technique used to understand how sensitive is our project to various risks. How much of scope, schedule, cost will get impacted due to those risks. Typically, tornado diagram is used to represent the sensitivity. Here, sensitivity means how sensitive those risks are in the project. Sensitivity analysis helps to determine which individual project risk or other source of uncertainty have the most potential impact on project outcomes. One typical display of sensitivity analysis is the tornado diagram, which represents element of risk analysis model that can influence the project outcome. As you could see, items are ordered by descending strength of correlation, giving the typical tornado appearance. Now let's take the tornado diagram from the application perspective. For this example, I took 4 parameters. Let's get into the first one. The element is contractor deliver early. If it happens, then the organization may make a profit of. Now we need to look at the right side blue color, which is about 2.5k dollars. If it doesn't happen, then the organization may make a profit of. Now we need to look at the left side of the chart for the element, which is 4.5k dollars. Let's take another example, the second one. When few fault found in hydro test, which obviously means less rework for the organization. So we make 4.5k as profit, and if it doesn't, due to rework, the profit margin gets reduced and we end up in about 2.75k dollars. Decision tree analysis. Let's discuss about decision tree analysis, also called as expected monetary value. Let's look at the problem statement. This is from the PMBOK guide, page number 435. A decision to be made whether to build a new plant or upgrade the existing plant. To build a new plant, you have to make investment of $120 million. If you have to upgrade the existing plant, then you have to make an investment of $50 million. The project outcome looks like this. If you build a new plant during the strong demand period, you are likely to make $200 million. During the weak demand, you are likely to make $90 million. There is a 60% probability for strong demand and 40% probability for weak demand. And when you upgrade the plant during the strong demand period, you are likely to make $100 million. And if it's weak demand, you are likely to make $90 million. There is a 60% probability for strong demand and 40% probability for weak demand. Now, the question is, which one will you choose? Will you build a new plant or upgrade the existing plant? Let's do the math. Let's keep the thing simple. The calculation is quite similar in all scenarios. So I'm going to keep only build new plant scenario. For easy representation, let me add some colors. Investment, I'm marking in orange. For strong demand, I use green color. Weak demand, I'm marking in cyan color. Let's calculate the profit. How to calculate the profit? Let's take out the revenue, which is 200 million in this case, minus the investment, which is 20 million in this case. That gives 80 millions. It's the first step. This $80 million is not the 100% assured profit. The probability of this event can happen is only 60%. So to calculate the event value, we have to multiply the profit by the probability. Here the profit is 80. Let's convert the 60% into decimal, which is 60 divided by 100 equals 0.6. Bring that value. By multiplying with profit, we get 80 multiplies 0.6, which is 48. This gives a calculated event value. Now, let's calculate for the next event. Start with profit. The steps are same. Take the demand 90, minus it from the investment 120, which results minus 30. Take the calculated loss minus 30, multiply it with the probability, in this case 40 divided by 100, which is 0.4. Bring the value to multiply. The result is minus 12. Let's combine the event value. The first one is 48. The second one is minus 12. The added value is 48 minus 12, which is 32. Let's do the same calculation for upgrade the plant. During the strong demand, the profit will be 120 minus 50, which is 70. 60% is the probability and it gets converted into 0.6 as decimal. Using that, let's find out the event value. 70 multiplies 0.6, which is 42. Let's do the same calculation for weak demand. In this case, 60 minus 50, which is 10. The probability is 0.4. The final event value is 4. Let's combine the event value 42 plus 4, which is 46. In expected monetary value, the higher the better. If you build a new plant, then $32 million will be the profit. If you upgrade the plant, then the profit will be 46 million. Among the two, obviously 46 is the higher value, so it's better to upgrade the plant. Influence diagrams. Influence diagrams helps to understand how a set of entities influence certain outcome. It's a graphical aid to make decision under uncertainty. Let's take an example. Typically in projects, there will be more low-cost resources, right? Generally, this is done to save cost and increase the profitability. We need to keep in mind the low-cost resources obviously will bring in less experienced, low-skilled resources. These low-cost resources will bring in their own risk into the project. One such thing is inaccurate estimate. This leads to time pressure and also quality issues. As a result, there will be too many unfinished and poor quality work. So, the cost gets overrun. To cover the cost, again, the management brings in more number of less experienced, low-cost resources. It's a chain. The risk of delivering poor quality continues to exist. Of course, here we are discussing a very simple example to identify the costs. But in reality, it's difficult to understand the cause in these kind of difficult scenarios. Influence diagram makes it easy to understand the cost and the effect. When there are multiple influences, they get evaluated using a simulation technique such as Monte Carlo analysis to indicate which elements have the greatest influence on key outcomes. Alright, now the outputs. Project document updates. The risk report will be updated to reflect the results of quantitative risk analysis. This includes overall risk exposure, which gets reflected by two key measures. First one, chance of project success, and the second one, degree of inherent variability. Let's talk about the first one. Chance of project success indicated by the probability that the project will achieve its key objective. Example, required end date or interim milestones, required cost targets, etc. Second one, degree of inherent variability remaining within the project at the time the analysis was conducted, indicated by the range of possible project outcomes. The key outputs from quantitative risk analysis are presented, such as the S-curves, tornado diagrams, and criticality analysis. Prioritize the list of individual project risks. Here we are talking about the risk that has the greatest threat or opportunity to the project, as indicated by sensitivity analysis. By repeating the analysis at different times during the project life cycle, the trend becomes apparent, which will help in planning risk response. The risk report may suggest a response to the level of overall project risk. These recommendations will form input to the planned risk response process. And that's the next process we are going to discuss, planned risk response. Meet you there.